Welcome and thank you for joining. Let's take a look at some interesting patterns in vector addition that will help us simplify vector expressions more easily. So first we're going to take a look at this triangle here, ABC. In this triangle we have vectors AB and BC that we're trying to add. So as you can see, vectors AB and BC are placed head to tail, so we can easily use the triangle law of addition. And we know that the sum of these two vectors will start at the tail of the first vector in the addition, so the tail of AB, right at A, and will end at the head of the second vector in the addition, so at the head of BC. So in other words, we're going to say that that would be the vector AC. Now, if you think about it again, as we mentioned, the resultant vector will have the tail at A, so it's going to take the tail of A, and we'll have the head at C, so it's going to have the head of C. So those are the first and the last letters in the addition. So when vectors are connected head to tail, and how can we tell? Because wherever one vector ends, the other one starts. So they have the same letters in here. Then the sum will be AC. Let's check and see if this works for quadrilaterals. So four sides, so if it works for all polygons in general. So in this case, we have the quadrilateral ABCD. So what we're going to try to do is add the vectors AB with BC with CD and see what we get. So we're going to do this the old-fashioned way. So we'll add AB to AC. They're placed head to tail. So adding AB to BC will give AC. So for the first two vectors here, we're going to write these two together, will make AC. And we can kind of tell without having to look at the diagram, we know that these two are placed head to tail because wherever one vector ends, the other one starts. So therefore, the sum of the two will have to be AC. So AC plus CD now, so that's what it simplifies into. As you can see here, we have again the same idea, so wherever one vector ends, the other one starts. So the resultant vector will have the tail at the first vector in the addition and the head at the head of the second vector in the addition. So that will make AD. Let's see if this works geometrically. We said this is vector AC. Let's draw it. Why not? And if we add vector AC to vector CD, so this would be the sum of the two. So it will start at A and at D, so AD. So as you can see here in this addition, the first letter we start with is letter A, and the last letter is D. So just by checking to see if the tails and heads are connected, so the B's, the head of the first with the tail of the second, the head of the second with the tail of the third are connected, then the answer will be made from the first and the last vector in the addition. Well, let's give it another try in a pentagon. So this time we have the vectors AB, BC, CD, and DE that we're trying to add. So we'll add the vectors A, B, and BC. So if you follow the strategy from the previous examples, we can tell that these two are connected, so the sum will be AC. But we still want to make sure, so let's see what this looks like on the diagram. So as you can see here, we have AB plus BC placed head to tail, so the sum must be AC. And that's what we thought it would be. So now these two together will make AC. So to this we're going to add CD and then DE after. So let's add AC and CD. Again, the head of AC is connected to the tail of CD. So we expect to have AD in here. But let's check and see if it works. So if we have AC added to AD, based on the triangle law of addition, this would be the resultant vector. So that's AD. So therefore, we're going to say these two vectors together will give AD. So here we go. This would be the sum. So we still have to add DE. So now we have to add AD to DE so that we can complete the entire sum. AD plus DE. There, place head to tail. The answer will be AE. And you can see that it works geometrically. So these two together will give AE. And as you can see again in this addition, where we have the heads and the tails connected very harmoniously, C's and C's and D's with D's, then the answer is vector AE. So if someone told you now that, oh, you have to add these 1 million vectors, just kidding, but these vectors that are connected to each other, let's say PQ with QR, with RS, with ST, it doesn't matter how long the expression is, plus TU, plus TV, plus VX, etc., etc. You can continue, but we won't here. We're going to stop it. And the answer will be equal to the tail of the first and the head of the last. I hope you find this interesting, and I hope this helps you with simplifying vector expressions. And have fun practicing homework. Bye for now.